Thanks, everyone, for coming. Raise of hands. How many of you saw the title of this presentation and thought, SOA, why are we talking about SOA again? A few of you. Today, we're going to share our journey, our SOA journey in Rackspace, and we're going to leave you with some takeaways that we hope you find valuable. This is a 30-minute talk, so we have a very simple agenda. We're going to give you context on who we are. We're going to show our legacy architecture. We're going to go over our SOA journey. We're going to talk about incremental SOA and then the takeaways. Who we are. We're a company that helps other companies move their infrastructure workloads from their data centers into ours or into the big public infrastructure providers, such as AWS, Azure, and Google. We have data centers across the world, over $2 billion of annual revenue, and we support half the Fortune 100 companies. Now I'm going to turn it over to Yogi, who will get us started.
Thank you, Marco. I'm taking you all back in time. This is the time close to 2009. We were not this big a company. We were making close to $650 million in revenue. We were experiencing some significant growth. We were growing 30% year on year. The growth means our systems got to scale. The businesses wanted to launch our services across a variety of different regions. We had, for a long time, operated with limited funding. We had acquired very many startups. And many of these startups, they had built their own legacy infrastructure. And many of these startups were used to building things in their own fashion. I mean, for a simple reason that funding was not available and many SaaS offerings at that time were not available. It was also used to building things their own way, doing things in the process that the business seems the right way. I mean, things, there is an industry standard way of doing it. There is a customer doing it. We were more used to doing things in our own way. What we had was highly technical group. I mean, for the very fact that they built everything, variety of systems, they were highly technical. They understood many different domains the way they could understand to the best of the abilities. So we had variety of systems, and we were trying to make sure that our systems scale for the kind of needs that our business was looking. So this is the kind of typical monolithic we acquired. I mean, we had acquired many different monolithics like that. So if you see what we have is a user interface. We have a bunch of APIs. We have a bunch of services. Our user interfaces, sometimes they spoke to the databases directly. Sometimes the user interfaces spoke to the services. I'm carefully using the word service and not service-oriented architecture because what we had essentially was web service. Our ESB is where most of our services got deployed. One big problem with this approach was when different services had different scale needs, the ESB was becoming a single point of failure. So, for example, systems like identity, they had different scalability requirements. When they scale, again, it could bring many other services down because they were all deployed together. If you see what we had multiple domains. We had customer, identity, billing, support, product. All of these domains were built into a huge database. It was a single database which was supporting all of these domains. We had many functionalities for many different cloud products we had, but all of those APIs to support those products, they were also funneled through these ESB. When these products experience significant load, any of those products, our ESB would again fail, our database would crash. All of this meant we couldn't really scale. It was really challenging. So I'm now going to talk about the SOA journey. So you all might be wondering why somebody is talking about SOA here. How many of you here know the languages like Greek, Latin, or Sanskrit? It's like 2 of us. Oh, you all know these languages? That's awesome. Not just Greek. Fantastic. So if you think that these languages are extinct, most of the modern languages like English, Spanish, Hindi, most of these languages, they derive largely based on these so-called extinct languages. If you take these languages, more than 70 or 80% of the thought, the content, the words, the grammar, it's all derived from what you call as these classical languages. Imagine you are a linguist. Would you just choose to study English, or would you choose to study all of the languages? That's the same thing that applies to SOA. If you think about microservices is a specific opinionated way of implementing SOA. So if you really want to care about true architecture, you would still study about SOA. So I'm going to give some examples here. How many of you remember the SOA principles? Okay, so let me recollect some of these principles. There's a SOA principles that called how we should go about building these services across an enterprise. They're well-defined principles. You got to learn these principles and apply these principles. And when you apply these principles effectively, you end up building services that are very useful for an organization. So I'm going to share some of the principles, and I'm going to share how they relate to microservices. For example, SOA talks about service reusability. What does that mean? You build your services in such a fashion that your services are usable across your enterprise. On the microservice world, build it like a product. Do you think it's any different? So SOA talks about something called the services should be autonomous. What does that mean? I mean, the services, there are two kinds of autonomies. There's a runtime autonomy, there's a design time autonomy. You should make your services as much autonomous as possible so that when any of your services, they scale, they don't affect the other services. It's the same logic that's applied in the microservice so that you segregate your services, you increase the autonomy by making sure that your services are deployed in using separate databases. There's another microservice pattern that talks about using asynchronous technologies for message interchange. So what talks about service loose coupling? You make your services as much loose coupled as possible so that one of the services, they don't become a bottleneck for the other services. So if you take many of the principles in microservices, I wouldn't classify them as radically new. They are some of the ways in which the operator has chosen to implement SOA. So this is something, another interesting thing. I mean, I have my father who is an English professor. He keeps reading Shakespeare, the original verses. I keep asking him, why do you read the original Shakespeare? Why can't you read an abridged version or an interpretation? He says, Shakespeare, he's like a philosopher. When I tend to read Shakespeare on my own, I get a different meaning. I don't want to get others' meaning. That same thing holds true for SOA. SOA is a philosophy. One of the implementation of SOA is microservices, and it's better as architects if we read the SOA as well so that we get the true understanding about SOA. And even with microservices, if you think you can just take all of the things that are listed in the microservices and apply to your organization, it's not going to be true. That's what this statement is. SOAs are like snowflakes. No two are alike. Does anybody know why two snowflakes are never alike? So every snowflake, as it falls from the sky, they grow through different temperatures, different pressure points. All of them, they shape the snowflake. So by the time a snowflake lands in Earth, the shape of a snowflake is not identical to another snowflake. Similarly, when we work in different organizations, when we work across different domains, different problems, the concerns we have in terms of scalability, in terms of performance, in terms of functionality, every place is unique. I mean, that's one reason why we are still having architecture running. If you have one prescribed architecture that could be applied everywhere, it's not going to be possible. So just like snowflakes, how they are different, the SOA and the microservice concepts, they're not going to fit right with your organization. You got to pick some of them, you got to understand, kind of see which ones fit for your organization and then apply them. So when we try to apply SOA within our organizations, the term microservice was not even popular, but almost most of the things what microservices are preaching now, we got them ahead, way ahead. Except that we did not write it or publish it, we were using some of these best principles just based on SOA as well. So what we are going to share is some of our learnings as we applied SOA into our organization and as we led an enterprise-wide transformation. So if you're looking at Einstein and thinking why I have Einstein here, two reasons. Anytime you have somebody like Einstein or Steve Jobs, it makes you look smart. So that's one reason. And the second reason is the quote. If you can't explain simply, you don't understand it well enough. That's a very nice quote. One thing that architecture needs to improve is explaining things to business as well as technical stakeholders in a very simple fashion so that everybody can understand the benefit. So when it came to SOA adoption, we had to convince our business that SOA is the way to go. What really helped us was with business, we used business terms in terms of increased return on investment, how we could be more agile, how our organization could use some of the existing investments. And similarly, when it comes to technology groups, that's when we kind of use a lot of these technical conversations. But the key point is you got to know your audience, you got to convince the audience. Anytime you take an enterprise-wide transformation like SOA, you got to convince many people so that they all buy in and they come along with you. Otherwise, this journey is not going to be successful. There are 2 points that I've listed here in the last. They are like SOA governance and SOA education. In general, we all have a bad taste for governance. I think it's our opinion around politicians. All over the world, we tend to associate governance with political people, and we immediately have a distaste for governance. But when it comes to SOA, I believe like you got to have some basic level of governance, at least an enterprise architecture team or a technical group overseeing it. Let me give an example. Yesterday, somebody was talking about an organization having 1,800 microservices. If you have 1,800 microservices, how do you ensure reusability? How do you make sure that organizations don't end up building the same thing over and over? So that's why it's important, like even if you talk about microservices which recommends less governance, I would say that we should have some sort of governance. Otherwise, we would never reap the benefits of SOA. And the second thing, I can't reiterate, SOA education. One bad thing about SOA is what has happened to SOA is like you search over the net, there are people who have written lots of material. It's kind of scary. You get like 8 to 10 books, each of them having like 2,000, 3,000 pages. It scares everybody and nobody really wants to read SOA. So what I would advise is like simplify SOA in a very concrete way and then share it with technical people. Share things that are relevant so that they can better understand and appreciate SOA. So here is another challenge we had. So way back when we had decided to adopt SOA, one of the first decisions we had to make was whether to build our services using SOAP or whether to build our services using REST. So Rackspace as an organization, we were some of the early pioneers of REST. Some of our products we had built using the REST APIs. They were very much welcomed by the customers. And similarly, initially we started supporting both XML and JSON. But by looking at the metrics, we soon realized that close to 80–90% of our customers were using just JSON and nobody was using XML. So it soon became clear that SOAP was losing its shine and REST is where we are headed. But here is one challenge. I mean, when it comes to SOA, everybody thinks that SOA is SOAP because the word SOA and SOAP, they seem to tend to be common, but that is not true. SOA talks about standardized service contract. As I said earlier, it's a philosophy which gives you a couple of principles. What kind of approach you choose to build your contract, what technologies you choose, it's very open. I mean, some people picked ESBs and SOAPs, that's one implementation, but that doesn't mean that SOA is wrong. So another challenge with this picking REST and JSON was we picked REST and JSON very early. We picked it ahead of all others. This meant that a lot of the tooling that was available for supporting SOA was not available in REST. I'll give you some simple examples. So SOAP had good extensions. There were extensions like WS Security. There were extensions like WS Beeple, WS Orchestration. Many of these were not available in REST. So it was left for us to go and discover. Even, for example, something simple like message exchanges. We realized that all our teams loved SOA so much. Our devs loved, DevOps loved, QAs loved. So we decided to build our own messaging system completely based on REST. It's an open source. In case any of you want to use, you can use it. It's called as Atom Hopper. It's an Atom-based RESTful messaging system. We had to build it because that time we did not have any RESTful messaging system. Similarly, there are common functionalities like rate limiting, throttling, authentication, and authorization. So we wanted a layer which can manage all of these, but we did not have any tool that could do all of this. So we built a service interceptor tool called Repos. It's again an open source tool. It allows you to do all of these in a very decentralized fashion, but centralized functionality. It provides service autonomy as well. So this is a platform that we had to build. One of the things that SOA talks about is something called as orchestrations. You have multiple services, but a business process is never a single step service invocation. It's a series of steps. There is a process is constructed using multiple steps in different services. You have to execute your process. So that time when we looked at the market and we looked at some of the orchestration engines, We couldn't even find an orchestration engine which could support all of this using REST. This meant we had to build our own orchestration engine, but we couldn't open source it. But the key thing is, anytime you want to adopt a technology very early, even before others adopt in the market, you might end up having to build things which necessarily don't add business differentiation for you. So that's something to be aware. If somebody wants to build microservice or SOA using gRPC, I mean, somebody was presenting yesterday, you're going to end up with a lot of ambiguities, and you might end up building a lot of tooling to support it. So once we standardize the REST, like SOA talks about service standardization, standardize on the technology that you use to build your services. But what really happened was, REST is not a protocol, REST is a state. So what exactly is REST? Everybody had a very different opinion. This is something called as Richardson's maturity model. It's a very famous model. This says the level 0 is like you start using HTTP. The level 1 is you start using resources. Level 2 is you start using HTTP verbs, and the last level is like you start using hypermedia. But we all, in principle, we agreed that we should shoot for the highest level, but we really did not know how to achieve that. So right from API versioning, right from managing these hypermedia links, right from pagination, there were a lot of ambiguities. So that's another thing to be mindful. So when you choose a new technology, don't expect just choosing technology is enough. You have to standardize. So what we realized later is just picking REST or JSON is not sufficient for us. We should have standardized additional aspects about REST. We should have standardized and formed an opinionated definition of REST and how our APIs are going to be implemented in REST. If we don't form it, the challenge is we had different teams within the organizations building the REST APIs. They all looked completely different. One another challenge was, even for simple things like API documentation, at that time REST did not have any tools. Slowly things are changing. Tools like Swagger, RAML, they are appearing now. But when you adopt technology very early, they might not be available. So we had to build our own documentation tool, but ideally we would have not built any of it. So just in case you're wondering what's the definition of REST as per Roy Fielding, he's the author who proposed REST. So according to him, anything that's to be called REST has to be hypertext driven. Please choose some other name that in case you're doing it other way. But unfortunately, the definition has gone beyond what he thinks it is. So how many of you know this guy? Yes, this guy is Larry Ellison. If there is one thing that he's famous for buying things. He bought, for example, MySQL. He bought Sun Microsystems. He bought PeopleSoft. He bought JD Edwards. He's successful by buying things. So this guy, Jeff Bezos, he's good at building things and selling it. For example, the entire Amazon Web Service was first built, and then it was built internally for Amazon, and then it was sold. So similarly, every organization needs to make build versus buy decisions. So if you don't have a policy around when you should build or when you should buy, you'll end up having long debates. As I said earlier, we had a highly technical group. They were more inclined towards building everything, but we also had people from enterprise companies joining our organization as we became big. They were very skeptic about building everything. They were suggesting these are things that we should buy. So it's important to have a policy when you adopt SOA around when you should buy versus when you should build. So this is another challenge we had, technology mismatch. As I said earlier, we chose to buy some of the COTS product. If you wonder what COTS is, COTS stands for commercial off the shelf. So the business is spending close to a few millions to buy a product. On other hand, our services, we have standardized REST as the technology to use for our services. So many of the COTS product we purchased, they inherently supported SOAP. And since we had standardized on REST, we couldn't use many of these products. So we had to build a heavy layer on top of the COTS products. So make sure that you buy products which align with the technology that you use for implementing your interfaces. Otherwise, enterprise-wide, it would get difficult. I mean, some people suggest even standardizing on more than one technology to handle this. And the second thing, I can reiterate this, trial and buy. Many of the commercial off-the-shelf guys, they promise a lot of things, but when you really go and try to make it work, many of it don't work. So make sure that you trial and buy. The last thing is, like SOA talks about vendor neutral contract everywhere. One challenge is there are class of systems, enterprise-based systems like billing, ERP. These are systems which never change. If you go about building services on top of them, on systems which never change, it's going to be a bit of a challenge. So apply kind of intelligence into whether you should build services on all class of systems or you want to choose and decide. So what really worked for us? What worked for us was incremental SOA. So one of the desires of our business was quick return on investment, handling the market pressure. So the way we worked was we built our service layers, some of them on top of the existing systems. We used some of the new systems we purchased as well as we bought for partial functionality which was getting into a bottleneck in the legacy system. And then we gradually moved functionality out of the legacy systems into the new system. What it allowed was it gave an option to roll back in case the new systems don't work. It gave an option to utilize some of the systems that we had purchased in a very incremental fashion, and this allowed our SOA to be successful. So with this, I'll hand it over to Marco, who is going to talk about some more incremental SOA. Thank you.
Am I on? So another example where we use this approach of incremental SOA is a project we started in 2015. How many of you use Salesforce? So you guys know how it can be customized and how you can get into the trap of customizing and every addition becomes more expensive. So picture that for 10 years. We have a system that has been around for 10 years, heavily customized. Every change was more expensive and it was not meeting the needs of the business. So we decided to create a new instance. And we took that opportunity to create services, web services that abstracted the two instances and at the same time implement a middleware platform that gave us real-time integration. So going beyond web services, we're talking about SOA, and most people associate SOA to web services. But the core concepts of SOA are abstraction, reusability. So we can extend those beyond web services. In this case, we extended those to two portals. Our identity portal, meaning that our customers can log in once, independent of whatever product they have purchased. Same concept with the billing portal. Now a customer can log in, see their invoices, make payments, and if a given business unit wants to create a new product, it's configuration versus starting a new project, new development.
So just in case you guys wondering why Bill Gates is here, Bill Gates talks about something called as trustworthy computing. The way he explains trustworthy computing is like in developed countries you never have to worry about things like water, electricity because they're readily available. You can focus on other things. Similarly, as an enterprise adopts SOA, you should build your services in such a way that a lot of the common functionalities like billing, identity, support, everything is taken, everything is abstracted. They're readily available for business units like some of the mundane stuff, so that it becomes easy for an organization to launch new BUs and they can focus on the core things rather than on the non-core things. I think that's where the platformization helps. By building platforms like identity and billing, these were platforms that were not just on the services, a complete platform, pluggable platform. When we launch new business units, these business units can simply plug into these platforms without any overheads. Thank you.
So takeaways. You guys have been through all this. Now we're going to give you some key takeaways that we think are valuable for any company. So SOA evolved into the concept that we see today. It evolved from SOAP to REST to microservices, and it will continue to evolve. But the core concepts of abstraction and reusability will remain. Go beyond web services. The two examples that we talked about don't focus on SOA only on web services. You can extend that to UIs. You can extend those to other layers. So I would encourage you to look beyond web services. And lastly, incremental delivery is critical for adoption. It is rare to have a project, funding for a project that is purely technical and it has one big release. As architects, we must look for opportunities to apply these concepts beyond the scope of a sprint. Thank you.
Thank you, Michael and Yogi. I think we have time for a couple of questions. If anybody would like to ask a couple. I don't know how I'm going to get there to repeat it. But
Model, API, standard.
Oh, Richardson's maturity model. Maturity model.
So the question was, what was the name of the model that you use?
For the APIs, yes. It's called Richardson maturity model. It explains different levels of REST APIs.
The different maturity models.
Time for another question? All right. Cool. Michael and Yogi, thank you very much.
Thank you.
Yep.